Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we will continue our lecture on continuous genetic algorithm. So we have discussed about the binary genetic algorithm previously. So today we look at the continuous genetic algorithm. So basically the continuous genetic algorithm is similar with the binary genetic algorithm. The only different is the representation of the uh, numbers. Instead of using the binary, we're using now a continuous number. So normally we will use floating numbers, which are from 0 to 1. Okay, so basically the flow is quite similar. We start with the initialization, and then we have our in terms of populations, so we call it chromosomes. Okay, so for the population we have, let's say we have 20 times this is for in terms of matrix. Okay, so we call it chromosome. So this one is chromosome number 1 until 20. So we have different variables to be optimized. So let's say we have 4 generators to be optimized in order to solve the economic dispatch. So we have 4 values that is between 0 to 1 representation. Okay, and then we do the fitness evaluation. Before we do the fitness evaluation, we need to decode. Okay, by using because our individual generators have their own minimum and maximum values of power. So we need to decode in terms of to get the in terms of value of the power. Okay, in terms of megawatts, and then we put all the results of the initial results for each chromosome into to solve the ED by using the cost function that we have discussed previously. And then we start. I think before that we need to do some ranking or sorting, so that the best results is located at the top of the populations. Okay. Then we go for the selection. So we can use roulette wheel. Normally I use roulette wheel, or you can use also tournament techniques, or can use random number. Okay. Then we go for the continuous GA operators, which consists of crossover and mutation. So this GA operators will continuous is quite different with the binary. So we look at here um, this concept or this technique later. And then again we do the fitness evaluation by decoding and using the cost function evaluation, and then we replace sorting the best result at the top of the populations, and will be continuously until the maximum attention is met. Okay, this is the algorithm flow. So we define the cost variables, select GA parameters, generate initial population, find cost, select mates for reproduction, mating, mutation, and convergence check. Oh, okay, but this one I think is quite some mistake here. So because even though that we have using the continuous genetic algorithm, we still need to do the decoding or encoding here. Never mind. So we look at it later. So variables and cost function that I mentioned previously. So your n-var is the number of variables. Okay, meaning that your dimension problem. Let's say we have 4 generators, so meaning that we have 4 number of variables. So we have the chromosome. So we have P1, P2, P3, and P4 if we have 4 generators. And then we do the cost functions evaluation. So here we apply into the ED cost function to get the minimum cost. Okay, but need to make sure that your cost function is fulfill the, of course, the inequality constraints with the generation. Okay, P min and P max, as well as inequality constraint. So the equality constraint is using the power balance equation is your summation of power must be equals to P load plus P loss. Okay, so this is must be fulfilled. So later I will show you how we want to use GA to solve the Chrome dispatch by using the MATLAB program. Okay, but this one is example is using height of map of the XY plane, so I think we can skip this one. Basically, you need to encode because yes, not encoding to the binary, but you encode into the continuous value. So normally I use floating number for the simplicity. Okay, floating numbers between 0 to 1. Okay. So in terms of population, we set the number of population chromosomes. Let's say previously we said that we have 20 population or 20 chromosome. So meaning that you have 20 in terms of row and times 4 of columns. Let's say we have 4 variables. So meaning that your variables or your population is 20 times 4. You need to remember that when we use the mating process, when you do the printing process, so we select the two of the parents, right? So we have dad and mom. Normally we want to produce two more offspring or child. Okay, so basically your population now become double, right? So that's why we need to use um, ranking or sorting function in order to make sure that all your the best results is located at the top of the population, and then you cut half in order to maintain the best 20 chromosomes. Okay, the rest for the 20 chromosome will be die for the next iteration. Okay, so this one is an example how we want to normalize and denormalize. So let's say we'll have our, okay, this is the example for how they do the normalizations. So basically, let's say we have our P1 is between 10 to hundreds, and then we have P2 between 15 to 200s. Let's say we have P3 between 20 to 250, and we have P4 between uh, 25 to 400s. So you need to first we do the initialization, right? So we do initialization, we just call the random number between 0 to 1. So let's say we have your Chrome number 1 is 0.5, 0.25, 0.7, and 0.9. So we need to do the denormalization before we can use to put all the values in terms of megawatts into the cost function, right? So we can use this thing. So you just times 0.5, 0.5. So in terms of P1 is times the range. The range is 100 minus 10 plus the minimum one. Okay, so you get this one is 90. 90 times 0.5, you get 45, right? 90 times 0.5, and then you times add for the 10. So you get now your P1 is 55 megawatts. This one how you decode. This one in terms of encoding. Now you want to decode. So let's take a look at your P2. Your P2 now is 0.25 times 200 minus 15 times 15. Okay, this is the range, maximum minus minimum plus the minimum. So your range is 200 minus 15, and then you times 0.25, and then you plus with the minimum 25. Okay, so you get your P2 now is 71.25 megawatts. So this is how you decode from the encoding values here. So you can do for the P3 as before. So next we go for the evaluation function. Okay, so after we do the evaluation function, we need to do sorting before we go for the natural selection. So This one is the rank chromosome. So we sort. So that's why this is your chromosome or your X in terms of 20 times 4. Let's say this one is 4 generators, and then your output Y, you have the cost. So you need to sort the best so far now at the uh, top of the chromosome or top of the population. Then we go for the natural selection. Okay, so you can use any function that you can use. So this one they're using the pairing methods. They go from the top to bottom. Okay, 1 and 2, chromosome 1 and 2, they do the mating or do the crossover. Okay, and then 2 and 3 and 4. So this one we call from top to bottom. Or you can use uniform random pairing, or you can use this one is weighted random pairing is similar with the roulette wheel. So later when we do for the MATLAB, we will look at the how we can use the roulette wheel. Okay, or you can use the tournament selection. Okay, and any others. So from my experience, I just use the roulette wheel, can get a very good answer. Okay, this is the selection. And then we go for the mating or crossover. You remember that for the binary, you swap the value, right? So you have 1 point crossover, 2 point crossover, or you have uniform crossover. So the simplest method, we can use swap variables. We just swap the variables for the, let's say we have chromosome number 1. Chromosome number 1 is 0.75. Okay, so bear in mind that your operators is using the value that you have constructed using the continuous number, not the one that you have decoded. Okay, so this one 0.25, 0.2, 0.9. So this one your generator 1, generator 2, generator 3, generator 4. Let's say they want to mate chromosome 1 with chromosome 3, let's say here. So 3 is 0.2, 0.1, 0.2, 0.7. This is example. So how we want to do the crossover? So you can use a simple method, just swap these two values, maybe these two values with these two values, we swap. Okay, and then you do, but the problem is no new information introduced. So this is the problem. And then here you need to rely the mutation for new genes, or you can use blending method. This one is Radcliffe, combine values of parent into new values. But this one also with problem, we give the problem, this will crossover. It's merely interchange data, no new genetic material generated. So that's why for continuous, normally I use the blending method, which is I give the P new, you use this equation P beta PMN meaning that which components PM whether this one or this one, you do the blending, and then 1 plus minus beta is a random number PDN. So this one M denote for mom, D denote for dad. Okay, N is which variables. Okay, 1 2 3 so forth. Okay, so which variables to blend? So all point of right or left crossover. So any selected view. So you can use, you can choose any of them. You can use by experimentally, or you can use also different beta for each variables. Okay. So the blending methods is very works well on several interesting problems that has been discussed in Michael Weeks. This one is a book you can find, book, the yellow book, Michael Weeks, that discuss about the GA that be implemented in the practical problems. But the problem is the values are bracketed by the extreme already present in the population, so must use the extrapolation method. So I also use the extrapolation method to avoid this. Okay, you can use blending or you can use extrapolation. So I use the extrapolation, or you combine the extrapolation with the blending method. Okay, the extrapolation introduces values outside range of parents. So you can use a linear crossover, 3 offsprings. You have 3 offspring, or and then you variable outside bounds are discarded and kept the best 2 offspring only. or you can use other factor than 0.5. So you can use anything. So this one is extrapolation method. Example, where your PMN is 4, meaning that the chromosome number 4 and chromosome number, not chromosome, the variables at the variable number 4, this one mom, and then this one variables for dad, number 8. So you just use this, using these things, and do the equation. Okay, we get a new lower and average and a new higher variables value. So this technique you can use, or the other one you use the extrapolation and crossover. This one I'm using, you can refer to Haupt, Randy Haupt. You can use the find the book on the internet. I think it's it's a free. So the title of the book is Practical Genetic Algorithm. Okay, so my PhD I'm using this technique for the crossover. Okay, where you select your parent, this is your parent, and then we select the variable which one want to do the crossover, which is, let's say this one, the new one, this one denote for the mom, alpha and beta here, and then you just minus p mom plus minus for p dad for the alpha. Similar for the p new, this one new your new solution or child. This one is child number 1, child number 2. Okay, so you just put these two into the p new here to get the new offsprings. Okay, all variables of the crossover point are swapped in offsprings. So this one is p union 1 until p number of variables. This one is p2 and until p number of variables. Okay, and then you can use your beta random value in range 0 to 1. So limit offspring variable to bounds of parents. Or you can use beta more than 1. Must then perform check out of the bounds problem. Okay. Then we move to the mutations. Similar with the binary algorithm, so you can use the mutation. You just simply select whether the components at each chromosomes to change. Just give the new values. We want to avoid the local minima treatment. Okay, so let's say we have mutation rate 20%. So high mutation rate is better exploration but slow convergence, because your results will be quite messy, because they just jump out from the results from the local optima. But if that's why you need to balance between the mutations as well as the crossover. Okay, and then you need to cap the elitism. So this one, you keep the best chromosome and population and never mutate. And then also you do not throw away a good solution. This is meant by the elitism. Okay, and then for the next generation, we insert the offspring into the population. We recalculate cost and repeat process until convergence. Max number iteration is reached, or you happy for some reason. Normally we just refer to the maximum iteration and then we stop. Okay, I think that's all for this topic. So we will discuss clearly later, and then if you have any problem, you can ask during the class for the next session. Okay, I think that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.